sklearn, metrics, pairwise, non-Euclidean distances. Description. This function computes the pairwise Euclidean distances between two arrays of vectors. Ignoring non-values, it calculates the distance between each pair of vectors in the input arrays. Considering only the non-nun elements for the calculation, the resulting output is a distance matrix where each element represents the Euclidean distance between the corresponding vectors in the input arrays. Inputs: X, an array of vectors with shape n samples 1. N features. Each row represents a vector. It can contain non-values. Y, an array of vectors with shape n samples 2. N features. Each row represents a vector. It can contain non-values. Outputs: distances, a distance matrix with shape n samples 1. N samples 2. Each element represents the Euclidean distance between the corresponding vectors in X and Y. Steps. For each pair of vectors X, Y in X and Y, iterate through each feature dimension. If both X and Y have non-nun values at the current dimension, compute the squared difference. Sum the squared differences across all features with non-nun values. Take the square root of the sum to obtain the Euclidean distance between X and Y. Metrics. Euclidean distance. This metric measures the straight line distance between 2 points in Euclidean space. It is commonly used for measuring similarity or dissimilarity between vectors. Visualization plots. Heat map. A heat map can visualize the distance matrix, representing the distances between vectors with different colors. Fine-tune parameters. None. There are no fine-tune parameters for this function. Uncertainty methods. None. There are no specific uncertainty methods associated with this function. However, you can consider using techniques like bootstrapping or cross-validation to estimate uncertainty in the distance calculations. Challenges and fixes. Challenge 1: handling missing values. None in the input data. Sample use case that resulted in challenge 1: input arrays contain missing values, which can lead to incorrect distance calculations if not handled appropriately. Fixes to challenge 1: the non-Euclidean distances function explicitly handles non-values by considering only the non-nun elements during distance computation. Challenge 2: computational complexity for large datasets. Sample use case that resulted in challenge 2: when dealing with large datasets, computing all pairwise distances can be computationally expensive. Fixes to challenge 2: you can consider using approximate nearest neighbor search algorithms, e.g. KD tree, ball tree, to reduce the computational complexity for large datasets. These algorithms efficiently find approximate nearest neighbors without computing all pairwise distances.